Here we have another example of a system with two loops. We have here a combination of inductors and resistors and an input voltage V. We are again looking for the equations that describe the behavior of this system in terms of voltages and currents. The resistor and the inductor here are swapped compared to the picture that you see in the exercise, but that doesn't change the final equations of this system. The first thing we need to do here again is to specify the loops and specify the directions of currents that flow in those loops. Our first loop could be this one here, and you can assume that there is a current I1 flowing in that loop. And here we have our secondary loop with the current I2. If you first look at loop 1, if we now add all voltages in loop 1, the result, the sum, needs to be 0. Or, in other words, the voltage drop across the inductor and the resistor equals the input voltage V. We can write V equals to the voltage drop across the inductor, which is the inductance times the derivative of the current. The inductance in this case is 2 Henry times the derivative of the current di1 dt plus the voltage drop across the resistor plus 2, the resistance value, times the net current through the resistors. Our reference current is I1, so that is positive. It goes downwards, and we have current 2 going upwards, so they go in opposite directions, hence the negative sign, minus I2. So this is for loop 1. If you now look at loop 2, it's starting up here with the inductor. The voltage drop across that inductor is the inductance, 2 Henry, times the derivative of the current, di2 dt. The voltage drop across the resistor is simply I times R, that is 2 ohms times I2, and plus the voltage across the inductor. Now our reference is I2, so currents that go in this direction are positive. If I2 is now positive, I1 is negative. So the voltage drop across that resistor is the resistance plus 2 times the net current through it, that is in this case I2 minus I1, equals to 0. Another way to write this equation, which doesn't change the equations at all, is to write the sum of all voltages here and equate that to 0. You see, the voltage drop across the inductor is in this direction. The potential on this side is greater than that side. Same goes for the resistor. When it comes now to the voltage source, we have a positive on top and negative at the bottom. When the current goes from the positive to the negative side, we assume that's positive. So you have the voltage across the inductor and the voltage across the resistor as positive values. And the current, when it goes through V now, it goes from the negative to the positive potential side, hence the negative. So we can now write minus V plus 2 di1 dt plus 2 I1 minus I2 equals to 0. If you now move V to the other side, V becomes positive. We go back to the equation we had.